Representation of compounds is a general chemistry and organic chemistry topic that shows up early and often on the MCAT. You'll see chemical formulas, Lewis structures, molecular models, and even chirality questions, all testing whether you can visualize molecules in 2D and 3D. If you can interpret how a molecule is drawn, you can understand its structure, properties, and reactions. And that's where a lot of points are gained or lost. Let's break down exactly how compounds are represented and how to read them like an expert. Chemical formulas, the basic code. Every compound starts with a formula. An empirical formula shows the simplest ratio of elements, like CH2O for glucose. A molecular formula shows the actual number of atoms, C6H12O6. On the MCAT, these questions test whether you can tell when a formula gives composition versus true molecular detail. Structural formulas, the connectivity map. Structural formulas show how atoms are connected by bonds. Instead of just knowing what atoms are there, you see which atoms are bonded and where. That difference matters because connectivity determines function and reactivity. Lewis dot structures, the electron picture. Dots represent valence electrons. Single, double, and triple bonds form when atoms share electrons to complete their octets. The MCAT loves testing which atom has a formal charge or incomplete octet, so always count your electrons carefully. Ball and stick models, the 3D blueprint. In ball and stick models, balls represent atoms and sticks represent bonds. This model emphasizes bond angles and geometry, like tetrahedral versus planar. It's what helps you picture VSEPR shapes in 3 dimensions. Space-filling models, the realistic view. These models show how much space atoms actually take up. Instead of showing bonds as lines, each atom is drawn as a sphere scaled to its true size. It's useful for visualizing molecular shape and steric hindrance, key concepts in organic mechanisms. Stereochemistry, 3D orientation matters. Stereochemistry looks at how atoms are arranged in space. Chirality is the big idea here. 2 molecules can look identical but be non-superimposable mirror images. One enantiomer might be a life-saving drug, the other completely inactive. The MCAT loves asking how to identify chiral centers and R&S configurations. Isomerism, same formula, different structure. Isomers share the same molecular formula but differ in structure. Structural isomers have different connectivity. Stereoisomers have the same connectivity but different spatial arrangements. This shows up everywhere, from alkanes to amino acids. Functional groups, the chemical personality. Functional groups define what a molecule does. A carbonyl makes something reactive, a hydroxyl makes it polar, and a amine makes it basic. Recognizing functional groups quickly lets you predict reactions and properties. An MCAT super skill. Representation of compounds is all about seeing chemistry on paper and in your head. Once you master how formulas, structures, and models connect, you'll find mechanisms, reactions, and stereochemistry questions far more intuitive. And that's where accuracy and speed come together on the MCAT. With that said, here are just a few of our student success stories, students who improved their scores and even got into medical school. If you're preparing for the MCAT, click the link below to get started with your own preparation. We specialize in helping students reach a 15-plus score guarantee, and we'd love to help you too. And don't forget, subscribe to our channel for more MCAT breakdowns like this, and follow us on Instagram for extra tips and resources.